Math people. This lesson is going to look at a first look at dividing for us in sixth grade. And I know you've done division before, but for most of us, it's a good review. Long division can sometimes feel like one of those skills that just gets easily forgotten. So it's good to get a refresher. So specifically, we're going to be looking at today dividing decimals by whole numbers. And we'll start with the basics. So the basics, in my eyes, are understanding the ways that you might see division written. And there are three ways that you might see division written out. And the first way is classic with that division symbol right there. So some number, I'm using letters here, but it could be any number, divided by another number. Another way you could see division written, we've talked about this a bit this year, but it kind of looks like a fraction. But if you see something written like this, it could also mean division. So if I had, let's say we had 3 over 1, that could also mean 3 divided by 1. If I had 18 over 6, that could mean 18 divided by 6. So although that looks like a fraction, that could also be written out as division. And the third way, which is going to be relevant to us today as we're doing some long division, some people call this the division house, but this is read as A divided by B. So if you're given a problem that's written in this format, let's say like 25 divided by 5, to set that up as long division, the first number goes inside the house, as we might call it, and the second number goes outside the house, as we might call it, and then you would do your division. So be aware of the three ways that you might see a division problem written and know how the numbers go. Don't get confused and think the dangerous thing is saying, oh, the bigger number goes inside and the smaller number goes outside, because that is not true and will not be true in many of the problems that we do this year. You can divide when the smaller number is on the inside of the house. So learn the correct order of things. It's first number inside, second number outside, not bigger number inside, smaller number outside. That is not always true. Do not fall into that trap. But let's start off with a non-decimal problem just to get back in the swing of things with long division. We've got 672 divided by 8. To set this up to actually do our division, the first number in the problem goes inside, second number goes outside. And so here's how division works. It's basically you just testing things out one by one. Can 8 go into 6? No, it cannot. So I'm going to try again. Can 8 go into 67? Yes, it can. So 8 can go into 67 8 times. This might seem like a small thing, but notice where I put the 8 in this problem. I tried to go into 67, and so the 8 is going above the 7. That's the number that it goes into, 67. So it goes above the 8. 8, or the 7, excuse me. 8 times 8 is 64. And now I'm going to subtract. The difference there is 3. There's a 2 that's in this number, and I'm going to bring it down since I didn't use it yet. And back to my line of questioning. Can 8 go into 32? Why, yes it can. It can go in 4 times, and 8 times 4 is 32. So it goes in 4 times evenly because there's nothing left over. So 672 divided by 8 is 84. That would be my final answer. And the answer to a division problem is known as the quotient. Let's get a little math vocab before we go any further. Quotient, that's the answer. And the two numbers that are in the division problem, the number that is in the inside here, this is known as your dividend. And the number outside here, this is known as your divisor. So we've got quotient, that's the answer, and then dividend and divisor, those are the two numbers that are being divided, or part of the division problem, I should say. All right, so now let's get into decimals when you're dividing. We're going to still be doing long division, so if you're still a little bit like, I need a little more work with long division, we're still going to do it. We're just going to put some decimals in, and nothing too crazy. Before you divide, if you have a decimal that is being divided, the number that you're breaking apart, when you set the problem up, you're going to bring the decimal up into the quotient before you start. And so let's look at a very simple example just to show what I mean by that. So if we set this up, 5 and 5/10 is inside and the whole number 5 is outside. Since I've got my dividend, the number inside, as a decimal, before I even start any work, I want to make sure that I bring this decimal up into the quotient. It goes right there. And now I will start dividing. Can 5 go into 5? Yes, it can. It can go in one time. Make sure you put it in the proper spot. Where you put your numbers, as silly as it sounds, it matters. It affects your answer. This goes above the 5 and it goes before the decimal point. So 5 can go into 5 one time evenly. There's no remainder there. I'll bring down that other 5. Can 5 go into 5? Yes, it can. And since I'm talking about this second 5, that's where the next one is going to go. It can go in one time evenly. And there's my quotient. Now, that's an easy problem, but it's just to highlight a few things. One, before you start, bring your decimal up into the quotient. And then once you've done that, when you are dividing, where you place your numbers in your quotient matters, so pay attention. Let's look at another example. For the second example, we've got 22.5 divided by 3. Notice how I'm writing this problem, just to get you used to seeing it written a different way. We had said that the first number is what goes inside, so 22.5 goes inside the house, divided by 3. All right, 3 can go into 2 0 times. Wait, before we start, we got to bring up our decimal point, put in the quotient. All right, 3 can go into 2 no times. 3 can go into 22 7 times. And since I'm talking about 22, my 7 goes above the 2. I'm lining it up. All right, so 7 times 3 is 21. When I subtract, I've got 1 left over. I bring down the 5. 3 can go into 15 5 times. Notice I'm putting the 5 above the 5 and the 15 because I'm lining it up. 5 times 3 is 15. There's nothing left over here, so I'm done. My final answer here would be 7.5. 22.5 divided by 3 is 7.5. All right. Now, there's a couple of things we should talk about. What happens if you have a problem where you think you're going to have a remainder? Because one thing about dividing with decimals is there is no more remainders. We're not having remainders anymore. So let's look at a problem that might have that scenario where you think, I think I'm going to have a remainder, but there's a way to avoid it. So let's look at that right now. We've got 4 and 374 thousandths divided by 12. In this example, the 4 and 374 goes on the inside, so let's set that up. And the 12 goes on the outside. All right, let's do this. First step, when you're dividing with a decimal, you want to make sure that in the answer, the quotient, you bring your decimal point up into your quotient first. All right, can 12 go into 4? No, it can go in 0 times. Can't go in at all. Can 12 go into 43? Yes, it can. 12 can go into 43 3 times. Line it up. And that goes in 12 times 3 is 36. 43 minus 36 is 7. I'm going to bring down this second 7. And here we go. Can 12 go into 77? Yes, it can. It can go in 6 times. 6 times 12 is 72. Subtract 77 minus 72 is 5. I'm going to bring down this 4. All right. Can 12 go into 54? Certainly. It can go in 4 times. 12 times 4 is 48. I'm going to subtract. 54 minus 48 is 6. Now, we're at a point where we've run out of numbers to bring down, but we've got something left over. Your answer is not 364 thousandths remainder 6. There's no remainders. So what we can do is we can add a placeholder 0. When I add a 0 to the end of this decimal, does it change the number? No, this is still 4 and 374 thousandths. In fact, I could add 100 zeros after this, and it wouldn't change the number at all. The value of the number is still 4 and 374 thousandths. So adding a 0 does nothing. But what it does do is it gives us another digit to bring down when we are dividing, and we want that. Because now, can 12 go into 60? Yes, it can. 12 can go into 60 5 times. 12 times 5 is 60, so it goes in evenly. Now there's nothing left over, and my division is complete. The complete and final answer to 4 and 374 thousandths divided by 12 is 3,645 ten thousandths. That would be my exact final answer. That is complete. There is no remainder, nothing left over. So if you get to a problem where you've run out of digits but you still have something remaining, you have to add a 0. And sometimes it's going to require adding more than one 0. You might have to add a 0, and then you might have to add another one. So it's okay to add zeros to the end of the number. It's not going to change anything, and you need to do that to complete your division problem. So be on the lookout for needing to do that. That, in a nutshell, is your intro to division. Use this lesson to help you complete the work with dividing decimals. If you have further questions, do not worry. We will hit this next time we're together in class. Do your best, and I will see you next time. Bye-bye.